Hello guys, welcome back to the channel Mathemagix JEE. The next question is saying let C be the set of all complex numbers. Okay, consider the function h defined from C to C defined by hz equal to iota times z. Okay, where I equal to root minus 1 or iota equal to root minus 1. Okay, then which of the following statements is obligate true? So we have this function. Okay, this hz as iota times z. Now think about this. This is related to the rotation of complex numbers. Okay, means when we, let's say, multiply this complex number z equal to x plus iota y by some iota, then we actually rotate this vector which represents this complex number z by an angle 90 degree in anti-clockwise direction. Okay, so like this, so this becomes iota times z. So let us use this concept here. In option A, it says H maps the unit circle S to S. Okay, so let us draw this first unit circle. Okay, like this. So we have this unit circle x square plus y square equal to 1. Okay, now take an arbitrary point on this unit circle. So z is here, let's say. Then if we transform this z by this function hz, which is multiplying by iota, then we get this new complex number. Okay, so we rotate this complex number along this circular arc. Okay, so we rotate this complex number by 90 degree in anti-clockwise direction along this arc of radius 1. Okay, so this complex numbers actually rotates by 90 degree. So we can see purely by geometrical observations that this complex number that we got by using this function h of z is again lying on this unit circle, because this unit circle is itself containing this arc of radius 1. That means the z will be traveling from here then to this point. Okay, so option A will be surely correct, right? Now let us check option B. H maps the complex upper half plane h equal to z equal to x plus iota y such that y greater than 0. Okay, so we have this complex half plane. Okay, so like this, we have this x-axis or y-axis, then we have this complex half plane which is y greater than 0. That means this plane, right? Now think about this. If we multiply this plane by iota, we actually are rotating this plane by an angle 90 degree in counterclockwise direction, right? So this plane after this transformation will look like this. So this will be y, x, and this will be our new h, or you can say after transforming this become h dash. So it is h, this is h dash. Okay, h dash is the image of h. So we can say h maps complex upper half plane h to h itself. This statement is not correct because we can see these two planes are different. This is upper half plane and this is left half plane, right? So this is the plane x less than 0 and this is the plane y greater than 0. So these two are different planes. That means option B will be not correct. Now let us check option C. H maps the unit square centered at 0 to itself. Okay, so we have this unit square. Okay, centered at origin. Unit square means side length is unity. So like this. Okay, this side length is 1, this side length is again 1. Now think about this. This is a unit square, right? So multiplying any point on this unit square with iota will give us another complex number which is 90 degree in counterclockwise direction to this old complex number z, right? So let's say if we take image of each and every point on this square, we actually are rotating this square by 90 degree in counterclockwise direction. That means this square will uh, in between look something like this. And then again, if we take the full image by 90 degree, we are actually rotating this square by 90 degree. So the square image will look like this. Okay, so as the square is symmetric about this origin and symmetric about all of the quadrants, that means this square will be same as the previous square. So we can say h maps the unit square centered at 0 to itself. This statement is also true. Now h of h maps a straight line passing through the origin to that line. Okay, so let us interpret this geometrically. Okay, so like this. Okay, we have a line here passing through origin, let's say. Okay, y equal to mx, let's say. Then h of h. Okay, so h of h will be what? We apply h two times. Okay, first we apply h, then again we apply h. Okay, so that means first we are applying the first h here, which means we are rotating this line by 90 degree in counterclockwise direction. So the line, after applying a single h or the h single time, will give us this line. Okay, this is y equal to some m dash x, where this m dash into m equal to -1. Okay, so this is the new equation of the line after applying h only one time. Now think about this. If we again apply h, we are going to again rotate this line again by 90 degree. Okay, so we will get this line itself, right? The first line, which is y equal to mx. That means we can say this h of h maps a straight line passing through the origin to that line. That means option D will also be true. So our correct option in this case will be A, C and D, right? So this is how we can apply pure geometrical interpretation to solve this problem.